From the core of a sun to the silent cold of deep space, temperature is the invisible force that shapes our entire reality. It controls why you sweat, why metal feels cold, why engines work, and even why stars exist. But what is it really? Why does a metal spoon feel colder than a wooden one, even if they're in the same room? Today, we're uncovering the secret dance of energy that rules our lives. Welcome to a deep dive into the science of temperature. This is the story of how energy moves the world. To understand temperature, we have to look smaller, at the level of atoms and molecules. Every object around you, including yourself, is made of these tiny, vibrating building blocks. Temperature isn't a substance, it's a measurement of average kinetic energy. As molecular motion slows toward its minimum possible state, temperature approaches absolute zero. In fact, the atoms and molecules in your body are vibrating incredibly fast, often trillions of times every single second, even when you're standing perfectly still. Common mistake: heat and temperature are not the same. Temperature is the average speed of the individual dancers. Heat is the total energy of all the dancers in the room combined. A swimming pool at 20 degrees has more total heat energy than a cup of coffee at 90, simply because there are trillions more molecules moving together in that pool. How do we measure this invisible motion? For centuries, we relied on expansion, the way liquids or solids grow as their molecules get excited and push apart. Celsius and Fahrenheit were built around the behavior of water, but scientists needed something more absolute. Enter Lord Kelvin and the concept of zero motion. Absolute zero is the limit. It's the point of near minimum molecular motion allowed by physics. It is the coldest possible temperature in the universe, a state of near perfect stillness. Scientists have come within billionths of a degree, but the laws of physics say we can never truly reach the great stillness. There is always a tiny quantum flicker of energy left. Because things grow when they're hot, engineers have to plan for it. Bridges have special expansion joints. Without them, the entire structure would warp, crack, or structurally fail. Even the Eiffel Tower grows up to 15 centimeters taller in the summer heat. That's the power of trillions of atoms pushing for just a little more space. Heat never stays still. It flows through three methods. The first is conduction. This is direct contact, kinetic energy passing along like a game of molecular billiards. Insulators, like plastic or wood, block this flow. A thermos works by having a vacuum layer, a space with no molecules, so conduction simply cannot happen. No molecules, no transfer. Engineers created aerogels, 99% air and the world's best insulator. You can put a blowtorch on one side and a chocolate bar on the other, and the chocolate stays perfectly solid. Next is convection. This happens in fluids like liquids and gases. It's a literal loop of moving matter. Hot fluids expand and rise, while cooler, denser fluids sink. But how does heat reach us through the vacuum of space? That's radiation. Energy travels as electromagnetic waves. No molecules are required for this journey. Everything above absolute zero emits radiation. If we had infrared eyes, you'd look like a radiant 100-watt light bulb in a dark room. You are constantly glowing with energy. When you add enough heat, things change fundamentally. Not just their temperature, but their state. During melting, the temperature doesn't rise at all. The energy is busy breaking bonds. Some things skip a step. At normal atmospheric pressure, dry ice sublimates, turning directly from a solid into a gas. It's a shortcut in the molecular dance, but it's dangerously cold. On Mount Everest, water boils at just 71 degrees. With less air pressure holding them down, molecules can escape into gas much easier. Pressure and temperature are deeply linked. Why does sand cool instantly while the ocean stays warm? Water is a thermal sponge. It takes massive energy to change its temperature, which is why oceans regulate our entire planet. Without this property of water, Earth would feel more like a desert planet, with wild, deadly temperature swings every single day. Water keeps us alive. We've mastered this science. A fridge doesn't create cold, it's a heat pump. By rapidly expanding a gas, its temperature plummets, a principle called the Joule-Thomson effect. These rules are governed by thermodynamics. The first law is simple. Energy cannot be created or destroyed, only transferred. You can't get something for nothing. The second law is about entropy. Heat always spreads out, moving from order to disorder, from hot to cold. Everything in the universe wants to reach the same temperature eventually. Over unimaginably long timescales, energy may become evenly spread throughout the universe, a state of perfect lukewarm balance, but that is trillions of years away. For now, we have the fire of stars. In their hearts, temperatures reach millions of degrees, forcing atoms to fuse together and create the very light and elements we are made of. In our labs, we use liquid nitrogen to reach temperatures that would freeze a human cell instantly. It's colder than the surface of Pluto and requires extreme caution. At these extremes, we find superconductors, materials where electricity flows without any friction. This discovery could help shape the future of our most advanced technologies. Back to our question. Why does metal feel colder? Your nerves measure the rate of heat loss, not the temperature itself. Metal is a heat thief. It pulls energy away faster. Because metal conducts heat so well, it drains your body heat much quicker than wood. Your brain tells you it's colder, even if they've both been in the same room for hours. Your senses can be lied to. Your body is a master of this balance. When you shiver, your muscles perform rapid activity to generate internal heat. It's your body's emergency generator. And when you sweat, you use your own body heat to turn liquid into gas, carrying the energy away. This natural AC system is what keeps us alive in the heat. So, from cold metal spoons to exploding stars, temperature is motion, heat is energy. Together they dictate the flow of life and the fate of the entire universe. Next time you feel the sun on your face or the bite of a winter wind, remember the invisible dance happening all around you. You are part of that dance. Thank you for going on this long journey with me today. I'm Adeesha, and I hope you never stop asking why. Subscribe for more deep dives. See you in the next discovery. This content is for educational purposes. All data was verified using peer-reviewed thermodynamic sources as of 2026. Stay curious and stay safe.